Hello, my name is Dillon. I'm currently a sophomore at the Dalton School, and this is the project that I've been working on for the past 6 weeks. It is a Geiger counter and GPS unit that both transmit data through XB to a computer, which can then graph the information, as well as map all the GPS and corresponding Geiger counter data. This is my project. This is just a simple Geiger counter. It is controlled by this AT-tiny microcontroller, which detects radiation through this Geiger-Mueller tube. This actually can detect alpha or beta particles, which come in contact with it. And when they do, it outputs a pulse to the microcontroller, which then controls the LED and buzzer. The Geiger tube is given high voltage power from the 555 timer, which boosts it from these two AAA batteries here. The AT-tiny, when it receives a pulse when radiation is detected, actually normally outputs a pulse through this pin here, and also outputs various data through the serial port here, such as counts per second, counts per minute, dosage, and all sorts of other information. At first, I just had it connected to this XB, which is a simple transmitter. It transmits data wirelessly to this XB over here. I was able to connect them together, and I have managed to make a graph that receives the incoming data and can graph the counts per second, counts per minute, the dosage in millisieverts per hour, and also displays the mode that it's in. That's just the sampling rate. So if I hold the sample of carbonite up to the tube, it blinks rapidly and beeps, and you can see the graph goes up quite sharply, and all the live data is output here. Now, I wanted to be able to make this project so that it can detect radiation levels over a wide area and essentially map where radiation levels are highest. So to do that, I attached a GPS unit to it. This was fairly difficult to connect because at first I wanted it to output both Geiger counter and GPS data as a single string, but in connecting the GPS up to the AT-tiny, I realized that this chip had limitations in terms of the amount of RAM that it had, so I had to think of another solution, which presented itself in this relay here, which switches between transmitting Geiger counter data to the XB and GPS data to the XB. It is controlled using this pulse out pin, which I repurposed so that it can control this tiny little chip here, which is just a simple transistor. It decides whether current can flow through or not, and in doing so, whether a little switch inside is flipped one way or the other, allowing either Geiger counter or GPS data to go through. This and the GPS are powered with 3 AA batteries because I needed a higher voltage than was supplied by these. And if you look at the graph, it will show that the GPS fix is void as of now because we are inside. So let's take a look outside. Now that we're outside, and the GPS data can actually communicate with the GPS satellites, and you can see that it has been able to get a GPS fix. Although it doesn't show the GPS data here, it is logging it, and I can show you the file that it's making constantly. You can see the counts per second and counts per minute data, as well as the GPS data here, as well as other data such as the number of satellites connected, the altitude, and the time. I collected some other data earlier, and this is what I got. I imported it into Google Fusion Tables and was able to get this nice looking map here that shows that if you click on it, shows the time, date, and other data of when it was collected, as well, which includes Geiger counter data, as well as the latitude and longitude. I can make a heat map of this, but also I can import it into Google Earth and actually show what each of the things looks like. In Google Earth, I can also see all the points. And once again, I can show all of the Geiger counter data at that specific location and time. My favorite part about BlueStamp has really been how, although we've had a lot of freedom to really design whatever we wanted to in our projects and really go all out on everything that we've done, all the instructors have really been supporting us so much and have been teaching us how each of the parts works, because if we don't really understand how it works, then we can't learn from this opportunity, and that's really what this is. It's an amazing opportunity to learn a lot of things that I never would have learned before. I would never have imagined making a Geiger counter and learning about how it all works, how the Geiger tube detects radiation, how GPS connects to satellites thousands of miles up in the air. And I've had some really great time building this, between all the amazing successes that I've had with this. It's really been an amazing time. The challenges themselves have been extremely annoying when they came around, but when it succeeds, it really makes up for all of the challenges that I've been through in making this project. Between connecting the GPS up to the Geiger counter, connecting both of them together to communicate with the XB and then to the computer, figuring out how to map it, all of that has been extremely annoying, but also extremely rewarding when it finally all worked together. Next steps for this project, I really think that the next step is going to be figuring out how to graph the data and actually map it perfectly. I've worked out a way to do it, but the result really is a better way to do it, and just figuring out how to actually network them together to make a succinct kind of heat map of radiation levels in a location, in a wide area. That's really what my end goal is for this project. I would also maybe like to boost the range of the XBs, but that's as simple as replacing the XBs themselves, and then it's just getting it all wrapped up nicely, which shouldn't be too hard. Just get an enclosure and put it in. So that's my project.